Hi, I'm Noëlle from the Worcester Polytechnic Institute. This is our exploration of how quantitative reasoning with visualizations vary across languages. In the paper, we show that when we give people estimation tasks in which they'd normally use numbers, but we replace the numbers with visuals and we do so across languages, then we learn that people's estimates differ significantly across languages. And we think that this can open new perspectives on cross-language studies in visualization. What led us to this research is that data visualizations today are now used in many places and in different languages. A few studies examined this intersection of language and visualization, and they showed, for instance, that color names do influence the verbal communication about visualization and data. Other research adjacent to visualization suggests that preferences for time representation sometimes follow the direction of written language. These studies surface the opportunities in cross-language studies, and they focus on categorical aspects of data visualization. But since data visualization is also and essentially about making sense and reasoning with quantitative data, we can then ask how such quantitative reasoning could vary across languages. In the paper, we narrowed the question down by focusing on probabilistic reasoning with icon arrays and in 5 languages. To find tasks that involve probabilistic reasoning, visualization, and language, we turned to the study of the interpretation of probability expressions. The work that informs ours is Kant's words of estimative probability. In this kind of study, participants are asked to assign numerical percentages to probability expressions like almost certainly, probable, etc. So we adapt Kant's study and we investigate instead the verbal versus visual representation of probability. And for that, we use icon arrays because they are known to be great at showing proportions visually and for communicating probabilities. To summarize, our study consists of 2 online experiments. One participant will see both of them, but in random order. Half will start with the Expression-to-Vis and other with the Vis-to-Expression. We work with a 10 by 10 icon array with orange and gray icons, and we use 18 probability expressions. We translated the study from English into Arabic, French, German, and Mandarin. And when participant takes the study, we prompt them with a fictitious scenario in which we tell them that they are drawing a tile at random from a set of 100, and that picking an orange tile means they are winning some prize, but their chances for that will vary with the orange to gray proportion. So now let's keep this scenario in mind and dive into the experiment. We named the first one Expression-to-Vis. So given the scenario I described earlier, we tell participants, you will likely draw an orange tile, and then we ask them to visually represent the proportion of orange squares that they think will help achieve such likelihood. We also say, vous allez probablement tirer un carré orange in French, and also in German, Arabic, and Mandarin, and each time we record the values that people draw on the icon arrays. A one-way ANOVA analysis of those values shows significant differences for expressions across the languages. So highlighting the example of the expression likely here. So except for the Arabic translations, murajah, which shows overlap with the original expression, the other 3 translations seem to have been assigned much lower values by the participant. For this type of cases, we searched for translations that were more aligned with the original English, meaning a pair of expressions that did not significantly differ. And we used a post hoc test for that, and we interestingly found cases where one expression would map to 3 translations, and also other cases where an expression would not have any acceptable match at all. Now on to the second experiment, called Vis-to-Expression, which is a reverse of the first one. We explore in this one how people describe the visualized probabilities. So participants will see icon arrays depicting different probability values, and then they are asked to select expressions from a proposed list. And we analyzed how people make use of the different expressions. So let's take the example of the Arabic version. It has the highest average number of unique expressions per icon arrays. For instance, 15 unique expressions out of the 18 were used for just a 40% chart. In contrast, the Mandarin version had the lowest average of unique expressions per icon array. And this could suggest that the 50 participants in that language were more consistent in the way they would use expressions to describe the icon arrays. Another interesting consistency is also that some of the translations that were proposed were barely selected by the participants. That's the case, for instance, for the translation of implausible, which was used only 7 times. So to conclude, we conducted a study in 5 languages where each study consists of 2 experiments, Expression-to-Vis and Vis-to-Expression. Within each language of the experiment, we observed a variability in the interpretation of probability expressions. So there is no one-to-one mapping between an expression and the way that the participants of the same experiment would map that into a visual. We also observed that in some languages, participants seem to be more consistent in how they talk about the icon arrays, meaning that there was less confusion in how a chart should be qualified. Comparing across the different languages, we observed that participants visually represent the translated expressions differently. Additionally, the expressiveness of the language regarding the visualization is not similar. In the study, we showed cases where participants did not have similar visual representation for a translation. So translation then, when used with visualization, is not always as straightforward as we would be used to with, say, verbal communication. Finally, our work is only one step in the exploration of data visualization across languages. The differences in expressiveness that we highlight suggest the need for careful choice of language when working with visualizations in multilingual settings. For instance, one might use expressions or language that do not necessarily resonate across cultures, which could then impact things like visual descriptions, presentation, what people take away from the visualization, and the communication and rhetoric surrounding data and the visualization. In the long run, we would like to extend our approach to explore different cultural dimensions beyond just language, so please do reach out to me if you like this kind of adventure. I would like to thank my colleagues and everyone who gave us feedback as we designed the study. Also, please check out our poster. It's also about language. We did it in collaboration with colleagues in Madagascar, where we investigated how people use data visualizations in their native versus secondary language. Thank you very much for your attention.